we do a little quick review for pages 15 through 29. We're only going to get through about maybe six pages or so today, and then I'll do another video for later. But you're going to have a quiz probably at the end of this week, and we'll see how it goes. If you have any questions, just email your teacher, whether it's Friedman, Wise, or myself. What I've got is on page 15, I'm going to kind of cut to the chase. I had taken the time to float all these little answers in, the added to, the yields, forms. Remember, the arrow is the reaction. So if I have solid metal plus oxygen gas, yields or produces, forms, whatever, that little arrow right there, that my plus sign, my little cursor is floating on, it indicates the reaction. So that's the yields or forms. S is solid. L, it's usually a little cursive L, is liquid. Little g is gas. Aqueous, AQ, means dissolved in water. And then we talked about there are 7 diatomic elements. What it means is when oxygen is by itself in the real world, it exists as O2. Nitrogen exists as N2, et cetera, for all of these 7 elements. That's not why water is H2O. If everything was diatomic, even in compound form, it'd be H2O2, and water would no longer be, water would be peroxide, which you already know. So the H2 and the O2, anytime anything gets together, it's because they're trying to get to the maximum, or trying to fulfill their electron, outer valence electrons. All right, so let's move on to page from 15. We're talking about the 7 diatomic elements. How do you remember it? We said, who's this guy? This is David Hasselhoff, but we've been calling him David Brinkelhoff. All right, so Brinkelhoff, BRINCL, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Those are your diatomic elements. Somebody came up with, when I was in college, of have no fear of iced cold beer. But, we don't drink, so. All right, so scientists starting, we talked about reactants and products. So if you look at on page 15, what are the reactants? You should have this answered in your book. But just as a review, reactants are what go into the reaction and they produce products. So reactants react and produce products, right? So reactants go into the arrow or into the reaction, and products come out of the reaction. All right, try and keep this not so. So the next section looks like this in your workbook. Hopefully it's all completely filled out, but I'll do the first one and then we'll talk about it, or we can, you can move on from there. What we have is a word equation that you have to turn into a chemical equation. And if you remember, when you see here, we have the word aqueous. Again, that's little aq. This pen is really hard to write with. Sodium, we look at the periodic table and we say, sodium, that is a metal. Whoa, going crazy here. Let's redo that. Sodium is a metal. All right. So sodium is wow, what happened to my pen? It's freaking out. This is so much fun. So easy to use. All right, so sodium is, let's try this one more time, maybe, a metal, right? So that's going to tell us that it is likely going to be ionic, an ionic compound, and that means we're going to have to deal with the charges, right? Equalizing the charges. All right. So I have to look at the periodic table, and I find that sodium in that first column is a +1. I didn't even have to look at it because we've been doing this for so long. Even though you haven't done it in 3 weeks, you still remember sodium is +1, right? And then to get the charge of sulfate, I have to look at the back page of the workbook, find sulfate, and notice that it is a -2 charge, right? So SO4 -2, and we'll say 2. So then when I do the chemical equation, sodium is, if you of course remember, Na plus 1. Sulfate is, I like parentheses even if I need them or not, SO4, right, minus 2. The charges are not equal and opposite, so I have to cross my charges. So the 2 here drops down. Whoa, freaking out again. Let's redo that. The 2 drops down to here, and the 1 is here, so it's just Na2SO4. Whoa, freaking out. I don't know how they do this. And then the plus sign here, plus, oh, and then again, it's aqueous. Aqueous. All right, now this pen, it's got a little clicky button on it that just is in the wrong place. Whoa, whoa, whoa. And then I have calcium chloride. All right, so I have to go calcium plus 2, chlorine minus 1. Wow, that's so annoying. All right, minus 1. So then that's Ca plus 2, Cl minus 1. And then I'm going to cross the charges. And the 2 drops down. And the 1 comes over. All right. And then yields or reacts to produce. And let me change my color here. Aqueous sodium chloride. Again, sodium is a plus 1, minus 1. So this is going to be super simple. This again is aqueous. So there's 2 liquids that are dissolved, excuse me, 2 substances that are dissolved in water. Aqueous sodium chloride is just going to be NaCl plus 1 minus 1. So those will cancel each other out. And this is aqueous. And then we'll pick something else here. That was unintentional. And then salt plus. And then here we have solid calcium sulfate. And again, calcium we already looked up, plus 2, sulfate we looked up, minus 2. So it's going to be Ca, and again, SO4. And here it's the solid. And I pretty much knew that if this reaction takes place, it's going to be a double replacement reaction, which comes later in the book, but since we've already covered it, it's going to be pretty obvious. But in a double replacement reaction, you're always going to end up with a solid precipitate. All right, so we just indicate that with a PPT. So you can pause the video and you can do, if you haven't done already, extension questions 2, 3, 4, and 5. You could do these now. You could check your answers on Schoology. The answers should be in the help section of the help folder. All right. So picking up on page 17, we're going to go from the chemical equation, and then we're going to change it to the word equation. So here I've got a metal again. So it's going to be non-covalent. It's ionic. So it's just calcium, and then oxygen is oxide. All right, there's no monos, dis, or tris here. Solid calcium oxide, so solid calcium oxide plus liquid H2O. We could say dihydrogen monoxide, but we're going to keep it simple and say liquid water. Reacts to form solid calcium hydroxide. And I'll write it on this side. All right, so you have to look at the OH and look on that sheet here, and you say, oh, OH here, that's hydroxide. All right, so you remember how to do that. All right, pretty simple. Pause the video. You can do the other ones if you have not already done it. If you have, great. If not, no worries. We're going to move on. All right, so here's where I was talking about types of reaction. So for this one, the first one, the synthesis reaction, the teacher captured hydrogen gas. Remember, we put it inside the egg and then we ignited the egg with the match and the egg exploded. Except for in one class, I know that one of the kids knocked the egg over and it didn't work very well. You know who you are. Okay, so the word equation, I have simply hydrogen gas I'm just going to simplify this, plus oxygen gas reacted to form water vapor. All right, and so here the chemical equation, hydrogen gas is H with a little g. And if you remember back to our Brinkelhoff talk, right, we said, hydrogen is one of them that has to exist as H2. So it looks right here, H2. Right, so we have to make sure we put in the H2 part. All right, so we have to have H2, gas plus O2 gas, again, diatomic element, yields H2O. And in this case, vapor is another word for gas. So how would you describe this synthesis reaction? Well, this synthesis reaction, right, is, I didn't know I had it written down, typed up, right? When two or more simple substances chemically combine to form a more complex substance, right? In this case, a compound, right? So that's page 18, synthesis reaction. Here we have decomposition reaction. Hydrogen peroxide was broken down. So this was the elephant toothpaste experiment. It was kind of really slow, but we put soap in it to show the bubbles and the bubbles of oxygen gas and liquid water. So I wrote it out as hydrogen peroxide reacts to form oxygen gas and liquid water. And then how would we write that down? Well, hydrogen peroxide, if we look at the chemical formula for it, is H2O2 reacts to form oxygen gas. Oh, and this was a liquid. O2 gas plus liquid water, H, that's a plus sign, if believe it or not, H2O, again, liquid, right? So the question is, how would you describe a decomposition reaction? Well, a decomposition reaction is a reaction in which a more complex substance, H2O2, a compound, is broken down and forms two or more simpler substances, in this case, oxygen and water. All right, so we'll go through and we'll do the other one. We said a piece of copper wire is placed in a clear solution of aqueous silver nitrate. The reaction occurs and the copper disappears and the silver appears in its place. So in this case, a piece of solid copper. So the word equation is solid copper, and I actually have these all typed out here somewhere. All right, solid copper plus aqueous silver nitrate yields solid silver and aqueous copper nitrate. And so the chemical equation would be copper, you remember, is Cu, and that's a solid, plus aqueous silver nitrate. So silver, remember, is a transition metal, but it's one of the ones where it's always a +1. So silver nitrate NO3, you look at that polyatomic ion chart in the back of the book and you find out it's a -1. So +1, -1. I don't have to add any subscripts to get my formula correct. Forms solid silver. Oh, and this was aqueous, sorry. Right? And solid silver, which is Ag solid plus aqueous copper, and this is supposed to be copper 2 nitrate. So this is going to be a little trickier. CuNO3 2. And then how would I describe it? Well, that's pretty simple. It's a single replacement reaction. One single lone element, in this case it's the copper, right, switches places with the silver, and it forms copper nitrate and solid silver, right, because the silver gets kicked out. And we had that story about we have all these little different like things to remember how things become, you know, why this does this. And we'll get into it a little bit in more detail coming up. But remember that we had said that the nitrate likes copper more than it likes the silver. And we'll explain how that works in a coming lesson. All right. So in the double replacement reaction, what we did is I took 2 clear liquids and we dripped one liquid into another liquid, and it formed that yellow, solid, chalky looking precipitate, right? So I took aqueous lead 2 nitrate and aqueous potassium iodide, and I formed aqueous potassium nitrate and solid lead 2 iodide. Remember, you always, in a double replacement reaction, you always form a solid precipitate. I should change color here just to make it easier to see this. So anyway, the chemical reaction, aqueous lead 2 nitrate, so that's going to be a Pb plus 2, right? NO3, 2, because it's a -1, plus 2, -1. Cross my charges. I can put the 1 here, it's optional. Again, this is aqueous plus aqueous potassium iodide. This one's simple. It's just Ki, because potassium is a +1, iodide is a -1. And that's aqueous. And it forms aqueous potassium nitrate. So that's KNO3. And again, +1. Wow, that's a bad +1. -1. So I don't need to do anything. My charges are equalized. And that's aqueous plus solid lead 2 iodide. So Pb, the Roman numeral 2 tells me it's a +2 charge. And iodine, I don't know, I didn't know why I put the parentheses around that. That was kind of silly. PbI2, because I is a -1, +2, -1, right? And then how would I describe this reaction? Well, in this case, I have 2 compounds, and you'll notice that the Pb and the K switch places. All right. When that happens, I get K with the NO3 now, and Pb with the I, right? The Pb joined up with the I. And this reaction only occurs if this precipitate forms. If this precipitate forms, that means this did not happen, yet it did. So I'm going to erase the little X. Oops. All right, everybody good? All right. So this solid precipitate forms. In a double replacement reaction, usually 2 metals in 2 different compounds trade places with each other, forming an aqueous solution, in this case the KNO3, and a solid precipitate, PbI2. All right. Moving on, combustions reaction. What I did is I took propanol and I reacted it with oxygen gas, producing carbon dioxide gas and water vapor. So what that looks like is propanol plus oxygen gas yields carbon dioxide gas and water vapor. So what I have to do is I have to know what propanol is. And I just happen to know that propanol is C3H7, I believe, OH. All right. And that's a liquid. Sorry about the bad parenthesis here. Plus oxygen gas, again, O2 gas. And then my arrow, carbon dioxide. So carbon, when you see the the prefix, you know that this is covalent. So it's just CO2 gas plus water vapor, H2O gas as well. And then how would you describe a combustion reaction? And a combustion reaction, a hydrocarbon fuel, in this case propanol, reacts with oxygen gas, O2, right? Here it is right here, O2, and forms carbon dioxide gas and water vapor. So you have to be really careful because that's usually what you always have in the case of a combustion reaction. All right. So how would you classify a reaction when a given chemical when you're given a chemical or word equation? Let me switch my tools here. And so you simply look at the reactants and the products and see how where they go, and what happens to the atoms, what happens to the different elements. All right. So in this case, I can take a synthesis and say, two simple substances chemically combine to form a more complex compound. And that's like taking substance A and substance B and combining them to something more complex. In a decomposition reaction, I've got one complex compound and it's broken down. Decomposition is breaking down, forming two or more simpler substances. So I've got AB compound breaking down into two simple substances separately. All right, a single replacement, we did that one where a single element replaces another element within a compound. So that's when I have lone A changes places with B, forming AC compound and B lone substance. Double replacement, I have those two elements within two compounds exchanging places. So in this case, the A and the C change places. So I end up with AD and CB. Combustion, hydrocarbon fuel, right, reacts with oxygen gas, forming carbon dioxide gas and water. So I've got hydrocarbon plus oxygen yields water and carbon dioxide. All right, so those are pages 15 through 20. We can do some of these practice reactions, types of reactions, but I'll save that for the next video. So, are there any questions? If there are questions, what you need to do is you need to email your teacher or wait till we have office hours and log on to the link they give you for your class discussion set. Since I teach two different classes and we're going to be meeting twice a week for an hour and a half, I'll separate it out so that biology is one half and chemistry is the other half. So hopefully things are going well for you, and I will talk to you if you have any questions. If you don't, great. If you do, email me.